Welcome to AQA A-Level Physics, Measurements and Their Errors, Estimations of Physical Quantities. Now before we come on to the table, let's first look at magnitude. Now the magnitude of quantities or a number refers to the size of that number or quantity. For example, let's look at 6 times 10 to the 4 and 4.2 times 10 to the 3. Now we can write that out in the normal number form. Like so. And we can see that this number, because of its gap here, is about 10 times larger, approximately. And because of this one gap, meaning it's 10 times larger, we say it's one order of magnitude bigger. Each order of magnitude bigger is 10 times. So 100, if a number is 100 times another number, it is 2 orders of magnitude bigger, or 10 to the second power. Now let's write this algebraically. In this case, it doesn't matter what A and B are, as long as they're normal between 1 and 10 in standard form. That's 10 to the x, and this is 10 to the x plus y. In this case, the bottom number is y magnitudes bigger. Because we can apply this up here. If this 10 to the x plus 1 plus y is this top number here, and x is the bottom number, x is 3, which means to get 4, y must be 1, and it's 1 order bigger, which fits this rule here. Let's look at 2 more numbers. 9 times 10 to the 9 and 5.11 times 10 to the 7. How many orders of magnitude bigger is this number than this number? Well, let's look at this. 9 and 7, these are both in standard form, so we can say it's 2 orders bigger. Suppose we have 40 centimetres of length and 0.4 centimetres of length. How many orders of magnitude bigger is this one than this one? Well, of course, because we have to do 0.4 times 10 to get 4, and then 4 times 10 again to get 40, it is 2 orders bigger. You should get the idea. Magnitude can be applied to anything really. If we come over here, the mass of a person is around 100 kilograms, and the mass of a car is around 1,000 kilograms. And we can see, because of these two numbers, mass of a car is about 1 order of magnitude bigger than the mass of a person, which means the mass of a car is about 10 times the mass of a person. Now, in your exams, you might be asked to estimate the quantity of anything, and you're going to be required to come up with that off of your own knowledge and common sense. This is a table of things here, which I found quite useful. I adapted it from a table off the Cambridge website. I believe power of a car, 60 kilowatts, power of a running person, 200 watts, and atmospheric pressure at sea level, 100 kilopascals, will be hard for you to see due to the glare through the windows. You don't necessarily have to learn this table for your exams, but it is nice to know the approximate magnitude values to get an idea of the scale of these, because you can then adapt it to the exam questions. For example, if you're asked what's the mass of a truck, well then we can look at the mass of a car, which is similar to a truck, and we know how big a truck is compared to a car. We can say it's about 10 times the mass. So we know the mass of a car, times it by 10, so we get 10 to the 4, and that's an approximate mass of a truck. And that's using your own knowledge, common sense, and knowledge of things like this. Although again, I do iterate, you don't have to learn this table, it's not required, although it is useful to know some approximate values. Anyway, that concludes today's video. Hope you learned something. Goodbye.